Okay, this will be our topic will be Newton's ring and interference due to wedge-shaped film. Already have written. Yeah. Okay, there's a experiment. So what we have is, so this part is a lens. Okay, no. Okay, look at the pointer, because this green color of hemispherical or solid hemisphere, no, it's a lens. It's a thin lens, thin convex lens. Or you can see things clearly here. So what it is, it's a thin convex lens of some refractive index mu. It is placed on a glass plate. This blue color one, what you can see, a glass plate. And what we have is next, the yellow color one, that's the air film. That nobody is there, like it's like a, so what is this yellow color one? It's called as an air film. It will be. I'll remove this yellow because you'll get confused with so much of colors in a page. Okay, there's air film. The yellow color region is the air film. So what actually this okay, let me explain now. So I'll take a thin convex lens. I'll place it on a glass plate. Okay, again, this glass plate is also very like it's having some thickness, not very thin. Then, then what we do is like, let me make the light incident on this one. Say monochromatic light of wavelength lambda. Let it be incident normally on this thin plano convex lens. What is this lens? This lens is again a plano convex lens. Okay, then. So what was our discussion? What we are going to learn from this particular chapter? So again, what is the basic thing is like, I want to find out the wavelength of the incident light. And how to find out the wavelength of incident light? The only best available method is like using the Newton's rings concept. Say monochromatic light will be incident. Okay, this plano convex light, thin plano convex lens. This one. So what is the main purpose of this discussion? So we can find out the wavelength of the incident light using this particular experiment. Okay, let me use the, yeah, let me start here now. Okay, fine. So a light which will be normally incident on plano convex lens. So will undergo first, as it is incident normally, so there won't be any refraction at this point. It will encounter a boundary or an interface. What is this interface? Glass and air. So what's happening to ray of light, this particular ray of light? It will move from a denser to rarer medium. So what do you expect? So this particular ray, after refraction, a part of ray will be transmitted, a part of ray will be reflected. There's a natural phenomena. There's a natural phenomena. You need not to bother, like whenever a ray encounters an interface or a boundary, a part of ray will be reflected back and a part will be transmitted. The refracted ray should bend away from normal because the ray is moving, because this is the denser medium. And what is the yellow color region? It's the air. So the green color region is what the lens, it is made up of refractance mu. So when a ray moves from denser to rarer medium, the ray will bend away from normal. Okay, that's what can say, like there's a normal. Fine. So this is the refracted ray. Fine. Okay, now what will happen to this reflected ray? Okay, the reflected ray by the curved interface now will encounter again a boundary here. Let's assume that one. So here, let it undergo, it's moving from denser to rarer, it'll bend away from normal. So this what the ray A what will get it. Okay, let's get into no this particular ray A. What are the like a phase of that one? What can be the phase of that? So look at the incident ray. Let it have a phase 0. Now with zero phase it will come. Now it gets reflected by a rarer medium. The air is a rarer medium now because the ray is moving from dense to rarer, reflected by a rarer medium. So will there be what will be the phase? What will be the phase? Will there be any phase change for the reflected ray? The answer is no. So what is the phase uh, angle of the reflected ray? Should be 0. Again, the ray what happen will encounter a boundary. It will move from, if this is a normal, it will move from denser to rarer. We know due to transmission, due to refraction, there won't be phase change. So what is the final phase of this? Will be 0. The ray A, what happened, will have 0 phase. Okay, got it? Now let's come for the refracted ray, the ray which got refracted into the air. So here, now what happened? It will encounter a glass medium. A part of ray will be refracted into the glass plate. Okay, I'm not bothered about that. And a part of ray, what happened, will be reflected by the glass plate. This is yellow color is the air. So the ray, what happened now is moving from air to the glass. It is moving from medium of A to medium of glass. So rarer to denser. So the reflected ray definitely will undergo phase change of pi radian. That's what you can see. I'm not bothered further what will happen to it. So this ray B, what is the phase of the ray B will be pi. Okay, now you can ask questions. So again, one more refraction is what will take place. So what is the phase of this? Should be 0. Due to refraction, there won't be phase change. Let me write. Okay, this is very important. This data. I think. Okay, yeah. I'll write it B here. Okay, now you see things clearly. Huh? So the ray A and the ray B is what the. Oh, what happened? Just wait. I'll get the screen. Okay, now look at the. Now look at the ray A and the ray B. So what is the phase angle of the ray 0? What is the phase angle due to reflection only? We'll have a path. Again, there'll be phase angle due to path only. So due to reflection, what is the phase the ray B acquired pi radian? What about the ray A? 0 phase. Okay, let's compare this two rays, ray A and B. So due to path, any phase the ray B will acquire. Now look at the ray A, will get reflected, will arrive here. What about the ray B? The ray B, what went first, it will pass through the air film, then it will pass through it. So definitely what when there's also phase due to additional path the ray B will cover in air. This one, so this much of additional path the ray B will cover in air. And what about this one? Optical path length will be same. The ray and ray B will cover almost the same path in the lens to reach this particular thing. So the ray B will cover additional path in air. So now what we have to do is like what is the path difference between the A and B? The total path difference. The path difference is due to reflection and also due to the additional length, additional path covered by the ray B in air film. Okay, let's come for this one. So what we write is like a 2 mu t, or so this will be like path difference is equal to. So what is any formula? How do, sir, how you can write things directly? Okay, let's get into the some derivations part. Path, find the radius r of the nth dark and bright ring. Okay, there's a question that is asked. So what is the path difference equation? We can write it as delta x is equal to uh, 2 mu t. So t is the thickness of that air film. So 2t is what? The additional path covered by the ray B in air film. To mu 2t will become optical path length plus lambda by 2. Further, we are searching for delta x should be equal to n lambda. Solve that and rearrange, then you'll get 2 mu t is equal to 2n minus 1 lambda by 2, where n equal to 1 t for the radius for the bright ring. So as mu equal to, what is value of mu for air? Will be 1. So therefore this will become, so the equation, okay, let me slide down. Okay, 2t equal to 2n minus 1 lambda by 2. This is the thing. Similarly for destructive interference for dark ring, so what is the expression now? Delta x is equal to 2n plus 1 lambda by 2. 2n plus 1 for the dark ring. So here delta x equal to, I think let me write the equations. So let me go for the equations. For destructive interference, so what we'll write it as 2n plus lambda by 2 equal to 2 mu t plus lambda by 2. Lambda by 2 gets eliminated, lambda by 2. So finally what happened, we'll end up with 2 mu t is equal to n lambda for dark ring. So 2t is equal to finally, as mu is equal to 1. For it, so 2t equal to n lambda. Okay, these are the some things what we can write with respect to the mathematics what we have available. Okay, let's see what we can. Okay, the total description is there. Now I want to find out the radius of the nth bright and dark ring. First of all, how the pattern that will be visible for the high. And sir, what do you mean by thickness T here? We are not understanding. Okay, let me put it all the. Okay, look at now. So the ray which is incident exactly at the optic center here at this particular point will not encounter any air film, will be reflected by glass plate. A fresh and so here what will happen, this particular thing will have a phase of pi radian or will gain additional path due to reflection by a glass plate. I mean this particular ray, I'm asking you to look at this ray. Will go there, will get reflected by glass and returns no. So what is the phase it will acquire? Pi radian, and the fresh incoming wave and the reflected wave by the glass plate. When they undergo interference, what do we get? The path difference will be lambda by 2. And because of that, what we see is like the central dark spot will be visible in the Newton's ring. Why in the Newton's ring pattern, the center of that pattern, why it will be dark spot means we can give a reason. Because the ray, which is exactly passing to the optic center here, goes undeviated here, get reflected by glass plate. It will undergo phase change of pi radian here. A fresh incoming wave and the reflected wave. What is the path difference between them? Should be equal to lambda by 2. So therefore, at the center, at the midpoint, we see a dark spot. A minima will be there. A minima will be formed here. Then, so next after this, okay, sir, why again bright and dark rings? So you look at the different rays. So this ray will encounter some air film thickness. Look at this ray, will encounter some air film thickness. So like that here, the rays which are incident at different parts of lens, after reflection happen, they'll cover different optical path length in the air film here in this region. And the fresh incoming, so like this, what happened, the rays, these two rays, what happened now when they undergo superposition, what do we get? We get the interference pattern. I'm interested to get the radius of the nth dark ring or the radius of the nth bright ring. how to calculate that one. Let me get into the mathematics. Let T is the thickness of air film. T is the thickness of air film. So here what we do is like, I think this D is given. Let me write T only. I'll take it out, this one, not needed. No. T is the thickness of air film. So therefore, what is this distance will be T. So the remaining distance will become R minus T. So let R be the radius of the ring. So when this I, what it will see the pattern circular rings of alternate bright and dark rings where the central spot will be a dark spot. The center of that pattern will be a dark spot. Then from this triangle, what we can write, this is R is hypotenuse. So R square is equal to R minus T whole square plus R square. See this one. Okay. Now let's expand this R minus T whole square. R square plus T square minus 2RT plus R square R square. So this R square will get eliminated. So what will be left over? R square is equal to 2RT minus T square. So this T in fact will be very small. So if you can neglect here only. If this T is very small, so if T is very small, the T square will be still more smaller value. So directly you can neglect this part. Will become, because T is very small, T square will be still more smaller quantity. So then what is the expression for T? Will be R square by 2 capital R. Okay, this value of T I'm going to substitute here. Put 3 in 192. This is equation 1 and 2. So I'll replace this T. Then I'll get expression for radius of the nth dark ring and the radius of the nth bright ring. So what are these? The radius of the nth and nth bright and dark ring formed in the Newton's ring, that one. Of all, very important, the center of the pattern will be a dark spot. Will not be bright, will be a dark spot. So now tell me, who is where is the film? The air film is what the very important here. The ray A will be reflected by the air film. The ray B will be reflected by the glass plate. So we are not bothered here lens. We are bothered about this air film. Why the pattern should be circular, sir? Why not other thing? Look at the convex lens. How the convex lens will be? Usually, what will be the convex lens? So convex lens will be of this shape, no? And a parallel beam of light, circular beam. This is a lens, and this is a circular beam. Will be incident. So definitely, what happened? So if you view from the top, you are going to see this alternate bright and dark rings. Different. The same setup if it is a instead of this. If the lens is of this particular shape, then if I send a parallel beam of light, I'll see alternate bright and dark bands here. Where do these things will be visible? Here only. So you can see on the surface what happened here. If you view normally, you are going to visualize that particular Newton's ring. If the same lens, if it is of this particular shape, like a rectangular lens, what you can call rectangular plano convex lens, then the alternate bright and dark rings, dark bands will be noticed here. Since the lens is of circular beam and the convex lens will be in spherical in shape, so we'll get the alternate bright and dark rings here. If the lens is of this particular shape, then we'll get alternate bright and dark bands. So that you can, there's a one possibility of asking some questions like a different shaped, like if the lens is of different shape, so how the pattern? So if it is like a, instead of lens of this shape, if the lens is like a pyramidal, you place like this. or I think I'm trying to, yeah, fine. And if a beam of light is incident, monochromatic beam of light is incident, then, so this as usual glass plate. They say, don't call lens. No, it's a glass structure. Like you can call like a prism or whatever that one. I think it will do appear like a, so pyramidal glass structure. Then how the pattern? The pattern is what? I'll get a frame, alternate bright and dark frames. Call frames here. This will be pattern. Okay, it all depends upon the type of glass structure you're going to place on the glass plate. Okay, fine. So these are the, I think the very core idea. What are the core ideas? What are the some core ideas? These things. The whole discussion start from a very small idea. The path difference between what? The path difference between race A and B. Let me write here. Similarly, the path difference between the rays A and B it is. And we have started here. Okay, I think this is very small thing. So what is the radius of the nth order brightening darkening? This one. So what is R dark? Radius of nth order darkening. And what is this? Fine. Okay. So we'll take the next topic, interference due to wedge-shaped film.